everyone. So you've already looked at two trends, the trend in atomic size, meaning like how big an atom is, and secondly at ionization energy. And so ionization energy meaning the amount of energy it takes to remove the outermost electron. The atomic size trend is that atoms get smaller as you go across the periodic table. We know that they get smaller because they have more protons. As you go down, the atoms get bigger because you're adding more energy levels. So the two trends in atomic size, as you go across, they get smaller. Again, you have the same principal energy level, but you're adding more protons, which makes your nuclear pull stronger. And as you go down, the atom gets bigger because while you are adding more protons, you're also adding larger energy levels. So lithium is like a size 2s orbital, whereas sodium is a size 3s orbital, and that's just bigger. For ionization energy, you have to picture how much energy it would take to remove the outermost electron on each of these atoms. And as the atoms get smaller, that electron is closer to the nucleus, which would be in the center of the atom, which means that those electrons are harder and harder to take away, which means as you go across the periodic table, the ionization energy increases. And as you go down the periodic table, the ionization energy decreases, again, because your center of your atom and the outermost electron are getting further and further away. Knowing those two trends is important for figuring out the last one, and maybe the most important one for moving forward. This last trend is called electronegativity, and it means how hard one atom pulls on another atom's electrons in a chemical bond, and we'll worry more about that later. But it's really just how hard an atom is pulling on electrons. Remember we said as you go across the periodic table, atoms get smaller, and that their ionization energy gets bigger because those outermost electrons are getting closer and closer to the nucleus that's pulling on them. So it takes more energy to remove them. Well, that also means that it's pulling harder on the electrons. That means as you go across the periodic table, the electronegativity increases, or the atom is pulling harder on the electrons. As you go down the periodic table, the electronegativity decreases, meaning that the atom pulls less and less hard on those outermost electrons. Remember, because they're further away. This is a table of electronegativity values. Notice the ones with low electronegativity values are on the left-hand side and they're green, and the things that have higher electronegativities are on the right-hand side of the periodic table, particularly in the upper right part of the periodic table. Notice that our most electronegative element is fluorine. And actually, kind of a quick way to figure out electronegativities is to say whichever one is closer to fluorine is going to be the more electronegative element. So if you were to ask yourself, for example, is potassium more electronegative than phosphorus? You say, well, no, phosphorus is closer to fluorine and therefore it's more electronegative. You can also read those values off the chart. Phosphorus has an electronegativity value of 2.19, whereas potassium's is lower at 0.82.